Hello everyone, in this video we're going to look at chapter 6, continuous distributions, continuous probability distribution. 6.1 is it introduced the uniform distribution. Okay, uniform distribution is pretty much pretty simple actually. X given the endpoint left endpoint A and B, so the probability is uniform. Uniform means everywhere is the same. Is 1 over b minus a. It's continuous. Okay, 0, x less than equal to b, bigger than equal to a. Okay, this is uniform distribution. So you look at the picture, the uniform distribution of this from 0 to 4 is 1/4. Fx is 1/4 from 0 to 4. So no matter where the point is, the probability is always 1/4. Okay, and then next one, we are going to look at the uniform, 6.2. Well, you may want to know the mean value of a uniform distribution is half of a plus b, the middle point, right? And the sigma square, the variance is 12 of b minus a square, well, which you take the antiderivative, you take the antiderivative, you use the formula, okay, use the formula doing, sigma square equals and fx x square dx minus x fx dx x square. So use that, you can find the antiderivative is that, okay? And then the 6.2 is normal distribution. We're going to have many problems about normal distribution. Normal distribution is a very important section. Okay. Normal distribution is in graph is called a normal curve. It has a bell shape. Okay, a bell shape. So most of the values will be gathered together in the middle interval. So most of them just in the middle range. Okay, we have a few extreme values on the left or right. So it has a bell shape and is symmetric with the mean value in the middle. So mean value in the middle is mu. Okay. So a continuous random variable have the bell shape distribution of 6.2 called normal random variable. The mathematical equation for the probability distribution of the normal variable depends on the two parameters mu and sigma. Mu is the mean value. Sigma is the standard deviation. Okay. So first, we want to introduce the normal distribution probability density function. So the density function is square root of 2 pi. Sigma is given the standard deviation 1 e to negative 1 over 2 sigma square x minus mu square. Okay, so x can be any number bigger than negative infinity, less than positive infinity. Okay, and pi is a constant number 3.1415. You know, e is another number constant 2.71828. Well, in reality, we cannot just plug it in. So for example, if I want to know what is f5, then you have to plug 5 into the probability given mean value, given sigma, and plug x equals 5 into the function to find the value. It's going to be really complicated to do all of them. So later we're going to introduce a way for the standard normal distribution. We can find the probability of all of them. Okay, so a distribution table. All right, so next, I think the next section it introduced the standard normal distribution, maybe. All right, so for this one, introduce the sigma mu1 equals mu2. They have the same mean value but different variance. The first different standard deviation. Sigma 1 has the standard deviation for sigma 1 is less than the standard deviation of sigma 2. You can see majority of the value just get together in the mean value. Okay, so not much variance. Okay, so this means sigma 1 is less than sigma 2 means almost everything is in the middle. Very few extreme values. But at sigma 2, you can see a lot of extreme values on both sides. Okay, so this one give you mu1 less than mu2, the height of the curve, because mu1 is less than, or sorry, not the height, the position mu1 is less than mu2 because it's on the left side of mu2. This is the x-axis, okay, and mu2 could be 10, mu1 is going to be 5 on the number axis, so mu1 is less than mu2. Okay. Sigma 1 has less extreme values. Sigma 2 has more extreme values. Most values are separate, scattered on both sides. Okay, so for sigma 1, most values gather together in the mean value. So not much extreme value. So sigma is less. Sigma 1 is less than sigma 2. Okay, and the mean and the variance of the normal distribution is mu and sigma. Mean and the variance is mu and sigma square. And the standard deviation is sigma. And then this has a proof, basically just according to the definition of mean value and the definition of the variance to find the mean value and the standard deviation. So next one is the areas and the curve, area and the normal curve. So the curve of any continuous probability distribution or density function is constructed so that the area under the curve bounded by the two ordinate coordinates x1 and x2 equals the probability that random variable assume a value between x1 and x2. So basically the area, the shaded region area, is the probability if x is bigger than x1 less than x2. Okay? And then if we look at the distribution, look at the definition 6.1. The distribution of a normal random variable with this mean value of 0 and variance is 1 is called a standard normal distribution. Because we will have, if you think about normal distribution, if for different mu and different variance, you have different normal distribution. And it's so hard, it's very complicated to find the probability for all kinds of normal distribution. So now we defined if the mean value equals 0, the sigma equals 1, standard deviation equals 1 is called standard normal distribution. Well, you may ask me another question. What if the mean value is not 0? What if it's not 0 and the sigma is not 1? For example, 10. Or so now it's not a standard normal distribution. Well, even if it is not a normal distribution, we still can convert the normal distribution. We can convert a normal distribution. For example, x minus 5. If I subtract everything with 5 from 5, then the mean value is going to be 0. Then if I divide everything by 10, the standard deviation, if the sigma is the standard deviation, then it's going to be a normal distribution n from 0 to 1. Okay? So that's how you can convert. You actually can convert a standard normal distribution into normal distribution into a standard normal distribution. All right. So next we are going to look at the given a z value. Since a standard normal distribution, you can find out you can use a table for all the probability of a standard normal distribution. Okay, we have a uniform table for that. Example 6.2. Given that standard normal distribution, find the area and the curve that lies to the right of 1.84. So basically ask you find out the right hand side, so basically means x bigger than 1.84. Okay, so bigger than 1.84 and equals, we can use the complement set is going to be 1 minus x less than equal to 1.84. Okay, then the distribution table will give you this value. You can find out this number because the distribution table will give you the number corresponding to left, okay, to the point. The distribution table will give you the area until 1.84, the left side. Okay, so you can use the table, find out 1 and 0.84, and you subtract that 0.9. You can find that number is 0.9671 equals 0.0329. The next one is probability of x between them is x less than 0.86, bigger than negative 1.97. Okay, so what you need to do, you just use probability of x less than equal to 0.876, subtract the probability of x less than equal to negative 1.97. Because, for example, you give the probability of less than, this is 0.86, this is negative 1.7. So you can use the probability, of all of them, subtract the blue one, which is less than this one, then you have the middle shaded region, which is what you need to find out between negative 1.97 to 0.86. Okay, so subtract those two. That's how you find out the probability value given a z-score. Okay, you can use, given a z-score, you can use the probability distribution table, the normal distribution table, to find out the probability. Okay, so example 6.3, it asks you find out z bigger than equal to k equals 0.3015. Basically, it means what is the probability of 1 minus p z less than equal to k. We can change this one into that and equals 0.3015. And you can solve p z less than equal to k equals 0.6985. And then from the table, from distribution table, you can find out the number corresponding to 0.9685. The area is given. So basically give you 6985. You find out what is the z-score here. Okay, you can backwards find the z-score. When you look at the table, this is a z-score. Okay, on the top is z-score. The middle values, all of here is probability. Okay, and the top on the left side, I think it's the left side is the z-score is the distribution table is negative 1.0, negative 1.1, negative 1.2, negative 1.3, negative 1.4, negative 1.5. So it has the probability for each one. So this is a z-score. Okay, the inside the table is probability. So next one is 0.11, 1.12, or negative 1.1, negative 1.21. Then for each one, it has a probability. It has a value for each z-score. Okay. So previously give you a z-score, you can find the number. Now give you a number, you find a corresponding z-score. So that's the example of 6.3. Alright, example 6.4. Given that a random variable x having a normal distribution with mu equals 50 and sigma equals 10, and this mean value, this is standard deviation. Find the probability that x is between x less than equal to 62 but bigger than equal to 45. And this is not a standard normal distribution. So first we need to convert that into standard normal distribution. How do we convert that? You x subtract by mean value x subtract 50, then give you a mean value 0. Divide by 10, give you a standard deviation 1. So if you do that on the x, you have to do everything on the other side. So minus 50 over 10. The same thing for 45. So you got 45 minus 50 divided by 10. Then we convert the x value into z-score. Z is less than 1.2. Z is bigger than negative 0.15. Then you can use b. Z is less than equal to 1.2. Subtract. Z is less than equal to negative 0.5. So you can find the probability corresponding to 1.2. When you look at the table, you have the z-score. You have 1.2. and 0.12, so 1.02 is going to be a number here, which I think is given here is 0.8849. Then you minus the probability corresponding to z-score is negative 0.5, is 0.0385. Then the probability is 0.5764. Okay. When we do the example in your homework, you can see again how to use that. How to use the distribution table to find out the probabilities. Okay. 6.5, you can skip that. I think you can look at the example of 6.6 as well. Okay. The 6.4 is application of normal distribution. Application of normal distribution, basically it gives you a normal distribution which is not a standard normal distribution. Then you have to convert that normal distribution into standard normal distribution, then find the probability. Example 6.7, we can look at the example 6.7. A certain type of storage battery lasts on average 3 years. So basically, the X, I should say X, okay. X, a base distribution 3, standard deviation is 0.5, is a normal distribution, okay. But it's not standard normal distribution. So assume that battery life is normal distributed. Find the probability that a given battery will last less than 2.3 years. So X is less than 2.3. Well, this is not a standard normal distribution, so we have to change that into a standard normal distribution. What do we do? We subtract the 3. If you subtract the 3, all the values subtracted 3, you will give you mean value is 0. Divided by the standard deviation, give you the standard deviation is 1. And less than equal to 2.3 minus 3 over 0.5. So basically you do the same operation on both sides. And then you got, this is going to be a standard normal distribution now. So it's z less than equal to negative 1.4. And then you use the distribution table, find the probability corresponding to negative 1.4. You got 0.0808. Okay, that's how you apply the standard normal distribution. First, find the z-score, then find the probability. Okay, you can look at the next few examples. They're very similar. Find the z-score, find the probability distribution. Okay, so let's see 6.5, normal approximation to the binomial. Okay, binomial distribution, we know that mu equals mp and sigma square equals mpq. Okay, this is binomial distribution, mean value and sigma. And if we get binomial distribution, if we have a lot of sample size, then the distribution of x minus mp over square root of variance, square root of mpq, this is based to standard normal distribution of 0, 1. Okay, so subtract the mean value, give you 0, divided by variance, give you 1. But it's the standard normal, but it has to give like the n goes to very big, n goes big. So then you have the standard normal distribution. Okay. Alright, so normally how big we need to be able to use the standard normal distribution to approximate the binomial distribution. Whenever there is a criteria for that. I think is whenever n times p is bigger than or equal to 5. Let me say if there is the where is the criteria. The criteria is I think the criteria is n is bigger than or equal to 30, like a big sample size, or I think it's mp is bigger than or equal to 5. Okay, somewhere it has a criteria for when you can use standard normal distribution to approximate the binomial distribution. Okay, there is a comparison table. This the left side is binomial, the second side is a normal distribution. So compare them. When mp is big, they are very close. Okay, especially when you see n is 100. When n is 100, okay, n is very big. mp is bigger than 5, then it's very close. You can say mp is bigger than 5 is very close. It's mp is 20 and probability p is 0.05. Okay, n is 20. So you can see when n is big, goes from 20 to 100, they are going to be more close to each other. Okay, when n is big, it's better. Okay, so let's look at 6.15. The probability that a patient recovers from rare blood disease is 0.4. If 100 people are known to have contracted this disease, what is the probability that fewer than 30 survived? So fewer than 30 survive, so basically you are looking for x is less than 30, right? And then we can find out the mu equals what? Mu equals MP. Mu equals MP, which is 100 times 0.4, which is 40. And sigma equals square root of 100 times 0.4 times 0.6, which is 4.899. Okay, so this is a binomial distribution. Out of 100, the less than 30 people will survive. If you use binomial distribution, you have to add, okay, choose 0 from 100, and 0.4 to power 0, 0.6 to power 100, plus 1 sin negative 1 from 100, 0.4 to 1 times 0.6 to 99, plus sin negative 2 from 100, and 0.4 to 2, and 0.6 to 98. Then you have to add until 30 to 100. Well, it's fewer than 30, right? So I have choose until 29, 0.4 to 29, and times 0.6 to 71. You can think about that. Even when it has a lot of calculation, not mentioned 29 calculations. So now we can use, since the n is 100, it's pretty big, okay? Given the MP is 40, that's big enough. So we can use a standard normal distribution to approximate it, okay? Instead of doing this, we're going to use the standard normal distribution to approximate the whole value of this whole thing. So what is the standard normal distribution? We have x minus MP over square root of MPQ. This based on standard normal distribution. So what do we have is, you can use that standard, you can find a z value. Z square is 29.5 minus 40 over 4.899, which is square root of MPQ, and you find this is negative 2.14. You see, this is much simpler. You just have one step, and then you can just use the distribution table to find the probability value. No, z. Okay, z less than equal to 0.14. Then just one step calculation, simple one. This, you just use a table to find the value, which is 0.0162. Okay, so you can tell, you can use the binomial distribution 1, 2, 3 at 29 of probabilities, and then, or use this is much simpler, right? The standard normal distribution to approximate binomial distribution is much simpler. Okay, you can view that. Look at example 6.16. I think it gave you another example again. Okay, 6.6 is a gamma distribution. Okay, it gives a gamma distribution. What is a gamma distribution? A gamma distribution is, a gamma function is given as, gamma function is from 0 to infinity x to alpha minus 1 e to negative x dx, for alpha is bigger than 0. Okay, the gamma distribution have several properties. Okay, so the property first one is gamma equation equals alpha minus 1 gamma alpha minus 1. Basically is the you can use this one to do this deduction. Okay, you can do the, I think it's by the integral parts. You can find this. Okay, and the second one is gamma 1 equals 1. Okay, gamma n equals n minus 1 factorial. Why is like that? You can continue gamma m equals n minus 1 times gamma m minus 2. Sorry, minus 1. Okay, then you continue n minus 1 times n minus 2 gamma n minus 2. Well, then you continue n minus 1 times n minus 2 times continue. The last one is gamma 1. And we find gamma 1 is just the 1. So it's n minus 1 times n minus 2 times until last number is 1, so gamma n is n minus 1 factorial. Okay, so gamma 1 equals 1, that's pretty obvious. You can plug gamma 1 into the function. You can find that gamma 1 equals 1. It's pretty easy to prove that. And gamma 1 half equals square root of pi. And then the gamma distribution, the probability distribution is defined as a gamma distribution. Again, the gamma distribution, we also do not use the handwriting. You don't use the computer to do all of this gamma integral. We also use a gamma distribution table to do that. Okay. Compare with the gamma distribution, the next one we use the more is exponential distribution. What is exponential distribution? Exponential distribution is 1 beta e to negative x over beta, and x bigger than 0, and elsewhere. Okay. Exponential distribution, we use it more often. We use it a lot. There is a relationship between exponential distribution and the Poisson process. Poisson distribution, in the previous chapter we discussed that Poisson distribution is what? It's a discrete distribution. Exponential distribution is a continuous distribution. Okay. In the course content, I think I have already gave a very specific example to explain the difference between the gamma distribution and also the Poisson distribution. And I want to explain that again here. What is the difference between gamma distribution and the Poisson distribution again? Let me find and see that again. So, gamma distribution. What is the difference between gamma distribution and a Poisson distribution? Okay, so there is an example 6.5. Let's look at the application of 6.5. I think 6.5 is exponential distribution. Wait, I think I want to look at the okay. So let's look at the relationship. So the relationship between exponential distribution and the Poisson process is quite simple. Poisson distribution was developed as a single parameter distribution with a parameter nominal. Nominal may be interpreted as mean number of events per unit of time. Okay, consider now random variable describe the time required for the first event to occur. Use the Poisson distribution, we find the probability that no events occurring in the span of time is given by the Poisson distribution. Now we can make the use of above and let x be the time of the first Poisson event. The probability that the length of the time until the first event occurred will exceed x is the same as the probability of no Poisson events will occur in x. So the second one is going to be a exponential distribution. Okay. Let's look at an example of a Poisson distribution and exponential distribution. So, for example, the number of hospitals newborn baby. Okay, the number of newborn baby in a hospital are based a Poisson distribution. Okay. For example, if we have every hour you have three babies born. Okay, 3 babies born, nominal equals 3. Every hour 3 babies are born per hour. Okay, Poisson distribution. Now if I ask a question, in the next hour how many baby will be born? Okay, how many baby will be born in the next hour? Even we know every hour the average is 3 baby were born in average. Okay, so in next hour nobody knows the exact number how many baby will be born in the next hour. Since in reality there might be 6 newborn babies, or just 1 baby born, or just 2 baby borns. We only know the average per hour is 3 babies are born, right? And however, we can use the Poisson distribution to find out the probability of newborn baby. For example, we have the probability we have 2 newborn baby, so n2. Okay, So equals in the next 2 hours, for example, in the we can use the Poisson distribution find out the probability of 1 newborn baby, 2 newborn baby, and so on. Okay, the probability of 1 born, okay, 1 or probability of 2 or probability of 3. So it's a discrete distribution. But there is another if we look at, for example, if we say, okay, in the next 2 hours, the probability of 0 baby is born is probability in next to 2 hours. For example, next 2 hours. Next 2 hours, 0 baby is born, so equals 3 times, okay, 3 times x, okay, square, and the power 0, and e to negative 3x, okay, square, and 0 factorial. Sorry, it's a 3 square, just a 3 square. Okay, the probability is a 3 square times e to the negative 3 times 2. Okay, and sorry, it's 3 times 2. 3 times 2 reads up to 0 power. Okay, so find this is negative, it's 0.0025. Okay, if I ask you in the next hour, the probability at least 2 baby are born, so it's a probability of n in the next 1 hour bigger than equal to, so it's 1 minus probability of n the next 1 hour, next 1 hour, and 1 minus next 1 hour is less than 2, which is 0, and you can minus, and less than 2, you can have one newborn baby, and then you have the probability is 1 minus 0 factorial, and 3 times 1 raised up to 0, e to negative 3. Okay, and minus 1 factorial 3 to the first power times e to negative 3 times 1 first power. Okay, and then you have the probability is 1 minus e to negative 3 minus 3 e to negative 3, which is 0.8009. Okay, this is use the Poisson distribution, find out the probability of how many babies will be born in the next 1 hour or next 2 hours. Okay, that's the use Poisson distribution. However, we may have, if we change the question a little bit, okay, is if we ask for the example, the time between 2 newborn babies in a hospital, the waiting time between 2 newborn babies. So we're asking the time instead of asking the number of babies in a certain amount of time. Now we ask the waiting time. The time is a continuous variable, right? We ask, okay, the time between 2 newborn babies in a hospital, the waiting time. If the waiting time is for the next newborn baby is t, which means during this period there is 0 baby born. So you're going to have probability of x bigger than t equals, there is no baby born during this time t, so p nt equals 0. You can use the Poisson distribution again. You get e to negative, you got the Poisson distribution is lambda t to 0 times e to negative lambda t over 0 factorial, which is e to negative lambda t. Okay, and then during this time, then there is a baby born in the during this time is p x less than equal to t equals 1 minus e to negative lambda t. Okay, so this is a continuous function now. Now in the next 15 minutes, okay, the probability of 1 baby is born is, you can use the probability again. Use this one next 15 minutes. Okay, so during the 15 minutes to 30 minutes, the probability of newborn baby is Well, then this is, you can use this this exponential distribution to find the number. Okay, so you can read this relation between the Poisson process, reading this explanation of Poisson distribution and exponential distribution. Poisson distribution is a discrete distribution. Exponential distribution is a continuous distribution. Okay. So let's look at application of a exponential distribution. Suppose that tiny phone 6.18. Suppose that telephone calls arrive at a particular switchboard follows a Poisson process with the average of 5 calls coming per minute. What is the probability that up to a minute that will be elapsed by the time 2 calls have come into the switchboard? Okay. The Poisson process applies within time until 2 Poisson events following a gamma distribution. Oh, this is a gamma distribution. So beta equals 105, gamma equals 2. And then denote the x by the time in minutes that transpires before 2 calls come. The required probability is given by x less than equal to 1 equals from 0 to 1, 1 over beta square x e to negative x over beta dx. Then you just need to plug the beta and the alpha into the probability. You got the answer is 1 minus. You can plug the beta and alpha in. You got the beta equals 115 because it has average 5 calls coming per minute. Okay, and the gamma equals 2. Okay, until 2 events following a gamma distribution, right? So this is you can find that is 0 to 1, 1 over 1 over 25 x e to negative x over 1 over 5 dx. Okay, so the answer is 0.96. Okay, and you can read the next few examples. Let me see which one is the exponential distribution. Okay, 6.21 is exponential distribution. Based on extensive testing, it is determined that at time y in years before major repair is required for certain washing machines characterized by density function. So 6.21, the density function is given fy equals 1 over 4 e to negative y over 4, y is positive and 0 elsewhere. The density function is given exponential function with mu equals 4. Okay, then ask you the machine is considered a bargain if it's unlikely to require major repair before the 6th years. And what is the probability that p y is bigger than 6? Okay, y is the random variable. Y represents the random variable, and it is the time before a major repair comes. This is how long we can use it. Okay, before we have a repair. Y is the time, which is continuous function. Okay, the time is a measurable variable, so it's continuous. Okay, py is bigger than 6. So now you can have, if it's bigger than 6, we always, when you do the probability distribution, you know you always have to do py less than equal to 6. 1 minus, you can find this. Okay, so now the distribution is given, the probability distribution is given, and that density function for it is an exponential distribution. Okay, so p bigger than equal 1 is 1 minus f of 6 less than equal to 6. You just need to find out the take the derivative take the antiderivative from 0 to 6. Okay, from 0 to 6, and you find the distribution fy is a exponential distribution, so it's 1 over beta 0 to y e to negative t over beta and dt, which is a the distribution cumulative distribution is 1 minus e to y negative y over beta. Okay, So y bigger than 6 is less than 1 of 6. So just subtract it. And y is 6. Y is 6. And 6 over 4 because mu equals 4. Okay. We just have to do that. And then is 1 minus f6. 1 minus f6 is 1 minus f of 6 equals 1 minus e2 negative 6 over 4. So the whole answer is e2 negative 3 halves, and which is 0.2231. Okay, this is a gamma. This is this is a application of a exponential distribution. Okay. You can also use, if you don't know how you do this, you can also, even here until here, y probability of y bigger than 6, you can do 1 minus y is less than or equal to 6. Well, you know time is half to bigger than 0, right? So you can do 1 minus the integral from 0 to 6, and 1 over 4. This is a density function, right? Fx dx, or ft dt, or fy dy. And the density function is given, so it's y minus 0 to 6, and 1/4 e to negative y over 4 dy. Okay, this is the density distribution. Okay, this is the fx. You know the probabilities. Take the antiderivative, integral from 0 to 6, 1/4. This is the density function. So 1 minus 1/4 is e to negative y over 4 divided by negative 1 over 4. Because this is a exponential function, you use the chain rule, divide by negative 1 4, then plug 0 6 into the function. So you got 1 minus, plug 6 into here, this will cancel out. So it's 1 plus, okay, 1 plus e to negative of 6 over 4, plug 6 in, minus, plug 0 in, so it's e to 0 over 4. So the answer is 1 plus e to negative 3 over 2 minus 1, which the answer is e to negative 3 over 2. We got exactly the same answer as well. Okay, you do not have to use that there's a fy, just directly use the definition. You still can get e to negative 3 halves. Okay, it's the same idea. So next I would like to introduce a little bit about chi-square distribution as well. The chi-square distribution, we're going to use that a lot in the later, when we introduce the t-distribution later, we have to use that a lot. But it's just we can introduce that, and we don't have to do a lot of calculations by hand. Okay, so chi-square distribution, the continuous random variable x is chi-square distribution with v degree of freedom. So this is the distribution table. You have the gamma function in the distribution table again. So 2 to the power v is a variable degree of freedom. Okay, gamma v over 2, and x v over 2 is actually v over 2 minus 1. Degree of freedom, subtract 1. E to negative x over 2. Okay, this is a gamma distribution density function. A gamma distribution has mean value equals v, the freedom, and sigma square equals 2v. Okay, and beta distribution also give you a distribution. We don't have a lot of calculations about a beta distribution. At most, probably sometimes to give you a problem, you have just use a table to find the probability distribution. In the next video, I'm going to look at all the homework with you together. Okay, so look at how to apply the normal distribution, exponential distribution to solve, and possibly we may have some gamma distribution as well in the homework, and see if you have any question as well. We're going to see the homework later. Okay.